Hello students. So today we're going to look at the rational zero theorem, which is a way to be able to factor and use synthetic division on our polynomials. You're going to want to have a notes, calculator, pen, or pencil. So what will happen when you're not given a factor or a hint of a polynomial like in yesterday's assignment when we did the x factor? What would we do? So what we're going to look at today is find a way for solve polynomials that cannot be factored. So basically what we're going to do is we're going to find a way to find your hint. So to find the hint, you're going to become a very educated guesser. So you're going to have a list of possible hints that are going to work. We're going to use the rational zero theorem. So every rational zero or solution of a polynomial is going to have this form. We call it P's over Q's. The P is the factors of the constant, basically the bottom, the end term. The Q is the factors of the lead coefficient. So, just some vocab flashbacks, guys. You're going to be getting only real numbers on here, okay? You're not going to be getting imaginaries yet. Because remember, real numbers was our fractions or the square roots or stuff like that. Imaginaries were with the I. So in this one, we're only getting rationals. So we're only getting stuff that can be made into a fraction. We're not going to be getting square roots today. So here's an example. We're going to need to find all the real zeros. So first, we're going to need to look at all of the factors at the end and at the beginning. So at the end, so my P's over my Q's. So my P is all the factors of the ones at the end. So all the factors of 8, aka what multiplies to give me 8? Well, I know 1 and 8 give me 8 when I multiply. 2 and 4 give me 8. That's it, right? Well, Q's then are the number in the front. So this is my Q. Put a little P by that so I don't get confused. Q is 2. So the 2 number multiplies give me 2. 1 and 2, right? Those are the only numbers. So then what we're going to do now is we're going to compile a list of our rational zeros. So basically what you're going to do is you're going to put every top over every bottom. So let's start out with the bottom of 1. So I'm going to have 1 over 1, 8 over 1, 2 over 1, and 4 over 1. Okay? Now, finished with 1 on the bottom. Now let's put everybody over 2. So I'm going to have 1 over 2, 8 over 2, 2 over 2, and 4 over 2. Now, simplify these down. But now, also, I can use positives and negatives of each of these numbers. Because think, I could have negative 8, negative 1 times a negative 8. So we're going to need to put plus or minuses with everybody. So 1 over 1, well, that's just 1. So I'm going to have plus or minus 1. 8 over 1, that's 8. 2 over 1 is 2. 4 over 1 is 4. Here's when it gets a little more interesting. 1/2, that's just 1/2, right? 8 over 2, that's 4. I have that taken care of. He's duplicate, don't worry about him. 2 over 2, that's 1. Taken care of right there. 4 over 2 is 2. Taken care of. So here's my list of possible rational zeros. Plus or minus 1, plus or minus 8, plus or minus 2, plus or minus 4, and plus or minus 1/2. So those are all the possible hints that may work in this problem. So now I have my possible zeros listed here. So what you're now going to want to do is use the list to find the actual zeros. Here's when you kind of hope you get kind of lucky. So let's try in some problems here. Let's try some of these numbers. I start with the lowest and go to the highest. So I'm going to start with 1 on the outside of my synthetic division. So let's set up our synthetic division. I got my x cubed, x squared, x, and no x columns. So I got 2, negative 5, negative 14, and 8. Drop my 2. 2 times 1 is 2. Negative 5 plus 2 is negative 3. Negative 3, negative 17, negative 17, negative 9. Frowny face. I need a 0 right here. So that's not working. 1 is not going to work for us. Let's try negative 1. set it up the same way. Okay, drop the 2. 2 times negative 1 is negative 2. Negative 5 minus 2 is negative 7. Negative 7 times negative 1 is 7. Negative 7, 7, 15. Another frowny face. Still not working. Oh, goodness. Let's try a positive 2. Let's see if I can get it there. Actually, you know what? I feel kind of lucky. Let's try negative 2. Let's see if that's going to work. So 2, negative 5, negative 14, and 8. Drop a 2. Negative 4. Negative 9. 18. 4. Oh goodness, I got my 0. And I'm going to put a big smiley face in there because that makes me happy. Found a 0. So negative 2 is one of my zeros. So let's go x equals negative 2 off to the side because I know that's one of my answers. I find a lot of students forget to write down the one they found that worked. So now, what you can do is now factor the rest of this guy. So let's rewrite my polynomial that came out of here. So 2x squared minus 9x plus 4. Now we can factor him using AC. So 2 times 4, 8. Here's a little trick, guys. If there's a plus here, you know you're going to have to look over here, and you know both of your signs are going to be this sign. So both of them are going to be negatives. So I know I need to use negative 8 and negative 1, because that multiplies to give me 8, but adds together to give me negative 9, right? So let's rewrite my middle term. Get to box here. I'm going to just not put the box around, just kind of put the sides. And 4. 2x this way, x that way, negative 4, negative 1. So I got x minus 4, 2x minus 1 for my two factors that came out of that. So if I solve that, I'll get x equals 4 and add 1 divided by 2, x equals 1/2. My 3 zeros, I have found them. Now I know I'm going to have 3 zeros because there is degree of 3. So usually you're going to have that number of zeros depending on how many degree you have. Let's try another example here. So I'm going to find all my possible zeros first. So my p over my q. So p is 9, so 1, 3, and 9 can all make that, right? And then 1 and 2 can make 2, right, when I multiply. So let's rewrite all of my factors. I'm going to have plus or minus 1, plus or minus 3, because this is all over 1, right? Then plus or minus 9. Now let's write the fraction ones. Plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. Double check, does anybody duplicate? No. Now, I am not going to jump in and try 9/2. That would be ridiculous. Don't even want to try it. Let's try with a 1. I like 1. It's pretty easy to do the multiplication. Let's write our synthetic here. So I got x cubed, x squared, x, and no x. So let's set it up. 2 there, negative 7 there. Oh, no x. Put a 0 there. 9 there. Okay. Let's do our synthetic. -5, -5, -5, -5. Uh-oh. Frowny face. Got a 4. Let's try -1. Let's see if that's going to work for us. Same setup. 2, -7, 0, and 9. Let's see if it's going to work. 2, -2, -9, 9, 9, -9. Big smiley face. I got a -9. Got a 0. So let's rewrite our new polynomial that we got here. We have 2x squared minus 9x plus 9. Because remember, since I start with x cubed, since I took out an x or a 0, I'm now down to x squared. So now let's factor this bad boy. 2 times 9 is 18. So 2 Probably 9. It's not going to make 9. What about 3 and 6? That makes 18, but I need negatives, because negative 9, those add together to give me negative 9. 2x squared minus 3x minus 6x plus 9. Let's box this bad boy. There we go. Can't have 2x this way because the 2 and the 3 don't share. So let's just go an x. But I can have a 2x that way. Negative 3, and then it looks like I got a negative 2 going this way. So I get 2x minus 3, x minus 2. So my answers, x equals 3 halves and x equals 2. Notice, guys, these are both in my list. 3 halves and... oh, 2's not in my list. Did I mess up on my factoring? Marsh did. Sorry, you guys. That should be a minus 3. My bad. Because 2 times 3 is negative 6. Who knew? So that's 3, so I should get a positive 3. So 3 is in my rational zero list. But don't forget the guy that gave you the smiley. Okay, so my other x equals negative 1. So, avoid some errors, okay? Be sure to list all possible negative and positive factors. So remember that you can have a plus 1 and a minus 1. Otherwise, you're going to be testing forever in the positives. And you could have tried negative 1, and it would have worked. And remember, not every zero generated by the rational zero list is an actual zero. Those are hints that may work. Some of them do, some of them don't. So try to choose the best one possible. I know it's frustrating. You could go forever, like we did on the first example. When you get back, I'm going to show you maybe a way to get a little hint easier, even better of a hint. And that's the end of this video. See you later, Sabers.